Hello and welcome to this introduction to the two DMA Aero test sets, air data test sets, recently introduced. The idea of this particular video is to give you a good idea of what they're capable of and then some instruction of how to drive the instruments. Initially, I want to tell you that the two instruments are very similar, except that one, which is the MPS 45, is a twin channel instrument, a conventional pitot-static altitude and pitot-total for airspeed. The MPS 49, however, is a three-channel instrument. Not only does it the conventional static and pitot, altitude and airspeed, but additionally a third channel for angle of attack, so that you can check out the more recent pneumatic angle of attack sensors on the aircraft. Here today we happen to have a three-channel instrument. This one that you're looking at is actually an MPS 49, just so that I can cover the whole of the characteristics. The 45 and the 49 have identical operating instructions until we get to talk about angle of attack. So I'm going to start by describing a 45 just as if we just had the two channels, static and pitot, and then go on right at the end of the exercise and talk about the additional capability of the third channel, the angle of attack. Okay, now when we talk about the capabilities of the instrument in terms of its performance and all the options available, I'd like to draw your attention to the straightforward data sheet covering the two instruments. At the moment, I have the data sheet for the MPS 49. There is an equivalent data sheet for the 45. And in these data sheets, you find all the information we hope that you're going to need. I'm not going to try and go through these now because time is of the essence, both for you and for me, because you'll get really bored. In addition, to tell you, we do have available and supplied at the time of the instruments a full operating manual, which should give you all the information you need on top of anything that I'm saying. It's a fairly large document, but it's nothing like reading War and Peace. So you should be able to get through it without any problems. Operating manuals is fine. In addition, we actually provide another manual, which is the calibration and adjustment manual. This gives you the ability to do calibrations of this instrument, generally speaking on an annual basis, in your own premises through your own calibration laboratories, if you so wish. However, if you would like to return it to ourselves, we will happily give you that service on a 1 year basis. Only remember that if you're going to do the calibrations yourself, it must be against first-class reference standards. There is the joke that if you compare it against a piece of string, you'll get a piece of string. You won't have a decent calibration. Okay, what we're going to do now is go on and talk about the instrument, generally speaking, on the front panel. Okay, so let's start looking at what we have on the front panel, just to cover it, to make sure it's fully understood. We have the AC input. That will run from any of the international voltages and frequencies you can probably think of. We go from 90 volts to 260 volts and something like 40 hertz to 440 hertz. So you're going to be able to run the equipment either on aircraft supplies or indeed on national supplies. You can also, as an option, have in addition a 28 volt capability if you wish, but that's an extra and it's an option. Moving on from there, we have the conventional things like the fuse, the power switch, etc. Coming down here, we have the ability to drain the instrument should we get condensation within the instrument. by pressing the center point there, it will actually blow out of the system any drops of condensation which have perhaps entered the instrument. Down in this corner, we have an external vacuum. That is because we also manufacture a range of pitot-static adapters, and one feature of the static adapters is that we use hold-down rubber cups, and this is the vacuum which would press the adapter close onto the fuselage of the aircraft. Moving over, we then have the remote control unit, which we'll demount in a moment and show you its operation. This means that in addition to running the controls from the main panel, you can also work from the remote, which can of course be very remote, since we supply, in addition to this cable, an 18-meter cable so that you can be in the flight deck of the aircraft. Then we come importantly to the actual connections to the pneumatics. We've talked about the pitot-static, we've talked about pitot, and let's just forget about angle of attack for a moment, since we're kind of talking about the 45 initially. On a conventional instrument, there you will have one static port and one pitot port. But what we find is that our ability to be able to give you switched pneumatic ports is extremely popular because it saves you a lot of time when it comes to doing leak testing, and we'll cover that more in a moment or two. And you can have any number you like, not just one, but you can have 2 or 3 or 4. Depends on your requirements. Coming down here, we have a capability to do programming on the instrument because we have a USB port there which enables you to connect to your own PC and drive the instrument from the PC, and in addition download the results of any tests that you do. The external port here is the unit that we use to drive the remote, and we shall do that quite shortly. We move on then to the top. They're the manual letdown valves. Generally speaking, they're probably never going to be used because the instrument comes with the capability to run on internal batteries, and the batteries will give you 2 hours of operation. This means that you can use the instrument if you wish away from AC supplies, and in addition, should you actually lose the power in the middle of a test, you won't see any difference. The power supply will take over and make everything safe, and that includes taking the test set and the aircraft down to safe ground levels. You can, just as a matter of interest, you can use the instrument without batteries internally. Then you would perhaps find yourself having to use the manual letdowns. We then come to the actual business of controlling the instrument and displaying, because we have this touch screen color monitor, and in addition we have a keyboard. The keyboard is generally speaking going to be used for entering test values, but in addition you can actually move around the screen via the keyboard if you wish, although I think most people will find themselves using the touchscreen. The box itself is weatherproof, it's rugged, it has a tow handle, it has wheels, it weighs approximately 15 kilograms, it has a lid which is removable so that it's not in the way while you're doing your testing. It's good to be able to take it off on occasions. While we're talking about the actual connections here, we use, generally speaking, the AN series of connectors, but you can have a whole host of variables. Okay, we have a whole host of different types of connector because people have different requirements. So, for example, we can use quick release self-sealing connectors if you wish. We have additionally straight connectors for pipes, and we have a variety of different types of quick release fittings, including the French versions. So you can have what you like in that respect. And from the point of view of how do we get to the aircraft, we supply you with hoses which connect through to the aircraft adapters. We tend to use transparent pipes which are color-coded so that they line up with the connections on the instrument. You can use different hoses if you wish. We tend to prefer the lightweight, coloured, transparent so you can see any rubbish which is got inside the system and make sure it doesn't get into the test set, although they do have filters to protect really big problems. So there we are. That's pretty much covered everything that we need to in terms of around the instrument. Now we'll get on and show you how it all works. I'm going to switch the instrument off and we'll repower so that I can show you the whole process right from the beginning when you start using the test set. We switch off by pressing the power key, holding it down for a few seconds. The instrument is now off, just as you would be before you start the test. Okay, if we now power the instrument back on, again, hold the power key for a few moments, and we fire up the instrument. You'll see that we get an introduction to the DMA screen, and onto that screen we will actually show the serial number of the instrument. We'll show how many running hours there have been for the internal pumps, and then we'll go through a startup procedure in terms of taking the instrument down to safe ambient values before we start. Well, we almost do. We have three different startup procedures. One, it will come straight online if we have a situation where we're very close to ambient. Fine. We have the other situation where you're not at ambient, but you're not too far away, and it's all specified in the handbooks of what we mean by not too far away, in which case the system will come online and bring the instrument down to ambient conditions, which if you look at the screen, from the point of view of the altitude, it's asking for ambient. Okay, so that's the second. The third, effectively, is if you come online and you're already at elevated values, we've assumed that that probably means that you've left off at a particular test point and you probably want to remain at that value rather than going all the way back to ambient. So for if it's at high levels, we'll come online at the exact values that you're seeing at that particular moment. It goes through the operation, it's doing it at the moment, it's in the control mode, bringing the test set down to ambient. And then we get the message. The venting is ended, the ambient pressure is reached, we're ready to start. If I press that, it brings us up and shows us the standard display with it ready to start operating. We have altitude, we have the rate of altitude, rate of climb, rate of descent, we have airspeed, and we have the rate of airspeed. By touching these, we can actually put in the desired values that you want to go to. So for example, I could put in 2,000 feet and press enter. We always have to press enter before anything will be accepted, just like on a computer. We can then move down to airspeed and we can put in some desired value for that. Let us say 150 knots, enter. Nothing has happened because at the moment we're actually in the measure mode, having come out of the ambient search situation. So to now go to those values, we go to the control key, and those two values will now begin to be approached. We have a rate of 3,000 feet per minute as the default, but you can change it to your heart's content, and we have 300 knots per minute for the airspeed. The instrument will take us to those desired values. It will, when it gets to the desired values, not overshoot by more than perhaps 1 digit. And the rate of climbs and the rate of airspeed will continue to follow the desired values until we come very close as it slows down before it reaches the actual value. We're nearly there. We asked for 2,000 feet, we asked for 150 knots, and we're now very close. In fact, we're so close that we enter a stabilization period where we come gently down and fix on the value that we wanted. Okay, we've reached the values. We could go on and add more test points. We can put whatever number of test points you wish. Eventually you'll reach the situation where you think, well, I better check that we haven't any leaks in the system. That's fine. We have the ability to go to the leak key. And in the leak key, when I press it, it switches off the previous screen and now introduces a screen that gives you the altitude value and the rate for both altitude and airspeed in terms of what is changing. If these figures show the altitude feet racing away, it means we've got a leak in the altitude system. Similarly for the airspeed. As standard, you have a timer here which shows you in seconds right up to the basic setting of 60 seconds where you are up to in the test. Here we are at 40, 41, 42 seconds. Maybe your test calls for you to leave it for a specific length of time. Fine. You can either do it in the way we're showing, or you can go to time and call in the number of minutes that you would like. For example, if it was 1 minute, as we have there, fine. You could change that if you wished. Then we go to go. And now, what you see on the display, instead of climbing up to 60 seconds, it's now going to count down the number of seconds that you've requested, because it might well be that your test routines on your particular aircraft call for you to do such and such a test at a particular altitude and airspeed, or indeed for altitude or airspeed. Both are capable of being done in parallel, the two, or individually. Okay, just before we go out of that, my mind is remembered in that we have this little battery sign here. That will tell us where we're up to in terms of battery charge. When it's got a C on it, it means it is connected to the AC. That would disappear if we went on to AC and would show you the actual value of the remaining battery charge. There we are. After the leak test we've just carried out, it tells me what changes there have been, which is exactly what you probably need for your instructions. Let's go back to that, and we have the ability now to put in new test values, whatever you wish. We can, of course, as I mentioned earlier, instead of pressing the button to go on, with these two keys here, we have the ability to increment round the particular capabilities. We also have the ability on here, with these up and down keys, you can use those to increment to the additional values that you would like to have. For example, we call for 2,000 feet. It might be that you're testing an instrument where you would like to investigate if there was something a little strange with it. Thinking of the older traditional instruments, maybe it's a little sticky. Maybe it's not moving on as smoothly as it should do. Well, with these keys, you can program that every time you press a key, it increases the altitude by a set amount. So, for example, I can press that and it's go to 2,500. Or come down again and I come down to 2,000. You're able to program these keys so that the value of those keys is in line with what you would like to have yourselves. At any time, we can go out of the control mode, as we are now, and go into measure mode. And that's where we were when we first started. I introduced the altitude value and then the airspeed value while we were still in the measure mode. And only when I went to control did they then begin to go to the values in question. That means that they started simultaneously to go to the values. If, however, you were in the control mode and you put in a new altitude, so for example, I'm into control mode. If I go to altitude and ask for 3,000 feet per minute, it will now go to 3,000 feet per minute immediately, and it will leave the airspeed exactly where it was. And it works vice versa, whichever you prefer. You have the ability to change these values you're looking at. They don't have to be in the values on the display screen at the moment. I could go, for example, and switch over between engineering units and aeronautical units, EU and AU. So if I press engineering units, I've converted it from looking at feet to looking at hectopascals, for example. I can do the same thing for airspeed. I can go to engineering units, and there we are again. Instead of looking at knots, we're looking instead at aeronautical units, pressures. I don't have to look at hectopascals. So if I go to units, I can look at all sorts of engineering units. Pascals, hectopascals, kilopascals, millimeters of mercury, inches of mercury, and so on and so on. You can decide which one you like to look at. Let's say we say inches of mercury, and there we are. It's now in inches of mercury, whichever. Anytime we want to go back to aeronautical units, there we are. And this one, aeronautical units. So that's fairly straightforward. What else do we have on here? We have a halt key. What's that all about? Well, if you are testing and for any reason you feel what is going on, you have the ability to press the halt key and everything will freeze at the value you are operating at that moment. Anytime you can come out of that by going to the measure or control mode. So there we are. Other keys, let's see. We have the ability on the keys, although it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, you can see that the keys have a secondary ability to give you more information, in which case we use the shift key, just as you would on a computer. So if I press shift, for example, and menu, it gives you the ability to look at other features, like the limits. I can change the limits. At the moment, if I look at limits, it tells me that, for example, my minimum altitude is minus 7,500 feet. My maximum altitude is 55,000 feet. My altitude rate is a maximum of 40,000 feet per minute. If you don't like those, you can change them. Make them safe for your particular exercise. However, when you switch the instrument off at the end of your testing, those limits you've just entered will be forgotten, and next time you start up you will have the situation where the previous factory fitted limits apply. You can change them permanently if you wish, but we don't allow that via the front panel. It tells you how to do it in the calibration manual, because that we feel is a different supervisory level to do that type of exercise. Okay, back. Let's go now to shift again and menu. Other things, we have function settings. You can change the settings that we're looking at, but here you need a password. That password again is to prevent anyone getting into this system who doesn't have the authority. And the same thing is for the functions and things of that nature. But that's what the menu key is all about. Other things. We talked about the remote. Now the remote is going to be very useful when you want to run the system from the flight deck. In that case, you need to go onto the remote, not the local. And we do that by the Shift key and the 4 key, the remote. And you see that we've now taken over, and you have a situation where everything you have there is here. And we can run the system from here if we want to. Going back, all we do is Shift and 4, and it brings us back. Do you want to exit remote mode? Yes. And we're back to the panel itself. It's easier for me with this particular filming video for us to work from the local panel, but you can change it whenever you wish in just the way we did then. The battery significance we've already talked about when we came earlier. The battery lives under this protective cover here. It can be removed, it can be replaced yourselves should it be necessary. Okay, we showed a few moments ago of how you can go into the leak test mode and then see what is happening to the aircraft in terms of what's on the static and the pitot. However, we've already pointed out many people prefer to buy multi-port so that they can cover the individual pneumatic ports you're using, for example, captain, first officer, standby, etc. People like to be able to then examine what is happening across the whole range and indeed find out where the leak is, if there is a leak. And to do that, we have the multiple isolator, and that's what these are. We have the ability to isolate any one of those to find out which is leaking. To do that, we go to the Shift key and the multiple isolator. And that screen then shows us, just as it did in the other full measurement mode of the leak, to the ability to select each one of these and switch it off, close it. So if we had a very large leak here, really significant, of course there isn't at the moment, but if there was, and we don't know which one is leaking, then we can go in and close S1. And that has now isolated that particular line. If the leak had been in that S1 line, maybe the captain, immediately that value that was showing a terrible leak would come right down and give you a sensible answer. If it wasn't, you can go ahead and close F2. You can do the whole thing right through and find out which one is leaking. It wouldn't be 4, or else we've got a real problem. With that, you can find out very quickly where the leak is, and it saves you all the heartache of having to go around the entire pneumatic system finding out which one is giving you headaches. And not just for the static, but we can also go to airspeed and do the same thing for the P1, P2, P3, etc. It's very good. It's a super system and people really like it because it saves a lot of time, and time is money. When we do any of these, it shows us what is happening. We know where we are in terms of which are open and which are closed. So I hope that shows you the value of having the multiple isolators. The multiple isolator feature does additionally provide other attractive capabilities. Via the individual port switching, it's possible to set up different parameter values on the different lines or channels. An example of this feature would be the ability to set different altitudes on the captain and first officer flight line instruments. This would then cross-check any differences that may exist, showing therefore potential errors. This feature must, of course, only be used when the lines or the channels have been checked to ensure that there are no leaks, because once the ports have been isolated, then the locked value will not be controlled. Finally, when actioning the opening of a particular closed channel, the MPS enters an automatic mode. It checks the difference between the current pressure, the parameter, as displayed on the MPS screen that may have changed, and the value that was originally isolated and is currently being shown on the instrument under test. If the difference between the current MPS control value and the original locked value is too large, then the MPS automatically changes the MPS controlled value to correspond to the original isolated parameter value before opening the closed port. This ensures that no sudden shock situations that could damage the UUT occur. What we've talked about to there, let's just go out of that situation, go to altitude, open up the ports to the same system as usual, press the shift key, multiple isolator, and we're back where we started. Very quickly, that's almost all the operating information that you need. There are other things hiding under the keys. For example, we have the ability to go to true airspeed or indicated airspeed, and you can enter in the ambient pressure. What else can we do? We can adjust the LCD to give you the different lighting that you would prefer. Servicing and parameters all described in the handbooks, and I think we've talked about all the keys here. So there we are in terms of how the 45 works, and incidentally the 49. The 49, the 3-channel instrument that has also angle of attack, you have a different situation in that you can now go in and address the angle of attack capability. So we'll do that now. Okay, just to show you how it works on the angle of attack, remember we've now got that other row, that 3rd channel. We could go, just for the moment, we could go to altitude, and I'm going to go to engineering units, because with the angle of attack you're going to be putting in as demand values pressure values, not true angles in degrees. Each probe has its own characteristic, and you will have the ability to put in the individual delta pressure values equivalent to angles. So we've put it into PS. I'm going to change it unit-wise to hectopascals, because I like working with hectopascals, but you can use whatever you wish. I'm going to input there 850 hectopascals, enter, control, and it will take me there. You'll see why I'm doing this in a moment. It just makes it clearer for you of what's happening. So it's going down to 850 hectopascals equivalent altitude, and then I'm going to go into the angle of attack screen. We're nearly there. What we have is the ability to go to the shift key and then call up angle of attack. If I do this, we're near enough now, shift angle of attack, you'll see I have the ability to change the display in terms of calling for airspeed rate if I wish, although that's the way of getting out of angle of attack. We can display PS2 so that we can compare PS1, which of course is the altitude. It's also the pitot-static number 1 port on the angle of attack probe, or we can look at angle of attack. I go for angle of attack. Okay, I can now input into the system the angle of attack value that I want. So I go here and I can put in, let's say, 30 hectopascals, and away it will go to the value that I've requested. When we get to that value, you've reached the value you want to test, but equally it's nice to know that the value between the PS1 and the PS2 on the probe is the right value. And I can do that now by going back to angle of attack and calling for PS2 instead of angle. And what you find is that indeed P1 has stayed where it was, and now PS2, the differential pressure if you like, we've gone up 30 hectopascals. We asked for an angle of attack of 30, we've done it, and we've demonstrated that as well as looking at the value we input, we're cross-checking it by actually seeing the two figures on the screen. We can then go out from that by going shift, angle of attack, go back to airspeed rate, and we've now put the screen back to where we started. Okay, so maybe now we've finished with the business of putting a value in for our angle of attack. We have the ability while we're in there to do again the multiple isolator. So if we go shift and multiple isolator, we can now check all three: altitude, airspeed and angle of attack. So if we have S1, S2, S3, we have airspeed, P1, P2, P3, and we have angle of attack. And so we're now addressing the angle of attack ports. And just the same way we talked about isolating which is the trouble port, we do the same on the angle of attack. We can now go back to the normal operating mode. And to do that, we go shift, angle of attack, and call for airspeed rate. And that then puts us back into the normal values, for example, airspeed and airspeed rate. Go to PS, and on PS go to our old friend aeronautical units, and we're back where we started. So fundamentally, that's explained the two-channel system and the three-channel system. I need to emphasize that you can convert the two-channel instrument, the MPS 45, into a three-channel unit retrospectively if you'd like to. Return it to ourselves and we can install the third channel for you. It's equally important to say to you that the three-channel instrument can of course be used as a two-channel instrument. That's what we've been showing you just. So whichever way you go, maybe when you're making a decision of buying new equipment, you need to think, well, okay, I only need a two-channel instrument at the present time, but I could be having angle of attack aircraft into my fleet relatively soon. So maybe you make the decision to have a three-channel instrument. Conversely, if you've had the two-channel, we can convert it for you later, whichever you prefer. I think I only now want to talk generally about some of the points I've already missed. The instrument has the ability to do programming. You can actually in here go into the programming mode and set up multiple different programs which can be given a specific name. Each program can have as many as 26 steps, in other words A, B, C alphabet. You can look at the answers to all those steps here on the instrument, or you can download them via the USB port into a PC. Equally, when we look at the data sheet, we had mentioned that it's got a whole host of options, and in there, for example, it tells you all about the remote control capabilities that you can have. This particular plate here can be removed, and you can fit into there, for example, an Ethernet interface, an IEEE 488 GPIB interface. You can have an ARINC 429 interface. We can have a grey code device readout. We can have Bluetooth if you wish, and a Wi-Fi interface. All of those are capable if that is removed, and that tends to shriek straight away. Those particular interfaces tends to mean that this is no longer a flight line unit. You're going to be using it in a laboratory or workshop environment, because you've then just removed the beauty of the weatherproofing that the standard box gives you. Okay, when we've shown you all these different things, the obvious final step is to vent the instrument down to ground. And we have the shift key and vent, and automatically the system will take itself safely down to ground conditions at safe rates. When the instrument is safe at ground, you're finished. You can pack up the unit. One of the things I've not mentioned to you, probably because you won't have heard it, is that the internal pumps of this instrument are very, very quiet. You may just catch it a little bit when it's in the control mode. Otherwise, it's totally silent. The pumps only run when they're needed. Otherwise, they go into a standby off mode. Okay, if you should need any further information, the best solution is to go to our website, which is DMA-Aero.com. Thanks very much.